All right, you guys, 3.2 is all about translations. And a translation is a transformation that maps all the points of the preimage in the same distance and in the same direction. AKA, if you're looking at this graph, you can see that this whole image shifts down together. And we write it, and we're talking about translation, so we're going to write that as a capital T using these brackets sub xy, and that sub x and sub y is going to tell you how many to move in the x direction, then how many to move in the y direction of triangle ABC to create our new triangle A prime, B prime, C prime. Don't worry about the properties, but do know that a translation is a rigid motion. So length and angle measure are preserved. We're not making it any bigger. We're not making it any smaller. We are just literally shifting the whole figure down. So let's jump into example 1. And for example 1, you need to jot down on the left-hand side these vertices of a given triangle, E, F, G, where E is at negative 5, 4, F is at negative 1, 5, and G is at negative 2, negative 1. We want to find the vertices of E prime, F prime, G prime for the translation. And if we look at part A, translation capital T, sub 6, negative 7, that means we are going to add 6 to our x value and subtract 7 to our y value. So it's going to move 6 units in the positive x direction, and it's going to move 7 units in the negative y direction. So the cool thing about this is we just take the coordinates that we were already given, that we know, and we do exactly that. We add 6 to the x coordinate, and we subtract 7 from the y coordinate. So if you're looking at starting at E, negative 5, 4, and we want to find E prime, for our x value, we're going to add 6, so that'd be negative 5 plus 6, which is a positive 1. And then to find the y value, we start at 4, and we subtract 7. So that's going to be 4 minus 7, which is negative 3. And we're going to do that with every point. So for each point, we're going to add 6 to the x value. We're going to subtract 7 from the y value. So f prime would be, the x value would be at negative 1 plus 6, which is at positive 5. The y value would be at 5 minus 7, which is negative 2. And g prime would be at negative 2 plus 6, which is positive 4. And the y value would be at negative 1 minus 7, which is negative 8. And now you know the values of those coordinates of the translation. So you're actually going to look at part B. Take a second, given your starting values, your starting coordinates, find the translation T when it moves 11 in the x direction and 2 in the y direction. Pause and try it. All right, let's check it. We should have added 11 to our x values. We should have added 2 to our y values, which would give us an E prime at 6, 6, an F prime at 10, 7, and a G prime at 9, 1. How'd you do? Hopefully well. If not, rewind, try again. All right, example 2 wants you to come up with the rule, aka what's happening. It says you start at point P, which is here at negative 3, 1, and we want to know what is the rule that maps us to our P prime, the image, at 2, 3? What's going on? How does it change? Well, we need to know the translation, so capital T, and we need to know the x and the y. So that's exactly what we're going to do. We're going to count in the x direction, if I could get my thing together. So I'm going to zoom in. We're going to start at our P, and figure out how many do we change in the x direction. So we go over 1, 2, 3, 4, 5. So we change x by a positive 5. And then what do? We go up 1, 2. We change y by a positive 2. So our full answer is it's a transformation of 5, 2. That's how it changes. We found the rule. And now we could do anything with that transformation now that we know how it changes. That was x plus 5, and that was y plus 2. Whatever our x and y's are, we could find it. All right, let's look at the next example, which is going to be our last one for this section, and it's about a composition, which composition just means more than one. So we're going to take just a little bit of notes. You can take them out to the side. Composition of a rigid motion is just a transformation with 2 or more rigid motions, aka we know reflections and now we know translations, in which the second rigid motion is performed on the image of the first one. And now what's going to be weird is they're going to look a little backwards. What we see here is this says reflection of line L on, this little thing means on or of, the translation of -2, 5 of this triangle ABC. So we actually do have to work backwards with that. So the first thing you would actually do is you would figure out the translation of left 2 up 5, because left would be negative. And then you would do the reflection of it across whatever that line L is. And we're going to use a small open circle to indicate a composition, that there's more than one thing going on. And you can kind of think of it as the second translation of the first one. So you are going to do it backwards. You're going to do this second one first, and then the first one second. Seems a little flippity-flopped, but that's okay. And so if we're looking at example 3, it says, what is the composition of the transformations written as just one? Okay, we're just going to combine them and say, well, what's actually happening? And if we're reading this, when we read it backwards, that means we first do this, then we do that. And we just need to combine those motions. So we're going to look at our x motion and then our y motion. So for our x, it says 1. So wherever we start, we'd add 1, and then we'd add 3. So that's just a movement of 1 plus 3, which means that x is going to move 4 units. For the y, we do the second one first, which means we start at -1. So wherever you are, you're going to go down 1. And then you're going to go down 2 more. -1 minus 2, which is -3. Remember that order matters when we're talking about subtraction. So if we were to write this translation, which is what it wants, what is the composition of the transformations just written as 1, we would say it's a translation where x moves 4, y moves down 3. And that's how we'd write it. So try that with part B. Look at your x values, look at your y values. Pay attention to the order. And let's check it. So we would start with an x value of a -2. And then we'd subtract 4. We get -6. We start with a y value of, we're moving 5, and then we don't move anymore. So that's 5. So that would just be -6, 5. And you guys, that's transformations. Like, that's it.